I guess everybody here is pretty familiar with these systems in the typical companies like HR, sales, finance, procurement, and vendors. These systems generate different types of data from employee performance, transactions, incomes, expenses, account payable, or cash flow, right? And these are what we generally know as the structured data. Now, those are what data analysis and data mining people have been working in the past, and they only represent a small portion of what the data that we capture today. And there are actually many other data like our emails, PDFs, Word documents, PowerPoint presentations, customer feedback, and product reviews. For example, right, if you are in the IT line and you have many emails and phone calls that's related to technical support, and if you are in the manufacturing line, then you will have access to many lab reports. And if you are in the banking and finance industry, then you have many legal documents and compliance reports to prepare. So there are a lot of insights, assets that can be extracted from this data, and we are not doing so. And this is what we call the unstructured data. And in fact, 80% of the enterprise data today are these sort of unstructured data. Now let's take this outside our work environment and then look at other data that we have generated. This is the number of actions that we take based on the activities outside our work. For example, the minutes of YouTube videos that we have watched, Instagram photos that we have scrolled, the tweets that we have read, etc. And these data are related to our entertainment, social, communications, shoppings, and even our relationships. And many modern businesses and tech startups actually are tapping on these opportunities so that they can provide better services and retain their customers longer. And these data are in the form of images, audio, videos, text, and these data are what the traditional softwares, ERP, CRM systems are unable to understand and analyze. And being able to analyze these data will give us a competitive edge and also business insights that can help us to take our businesses to the next level. And that's what we are going to talk about today, how to uncover business insights from unstructured data. And I'm your presenter today, Dr. Lau here. I'm a PhD in machine learning, majoring in NLP or natural language processing. So I was a keynote speaker for data science and developers event for Microsoft, Google, Facebook. Basically there to share my experience with developers and data scientists so that I can help them to close the gaps and they can understand both sides better. I was also the state advisor for smart city and big data analytics initiatives, helping the state governments to identify viable solutions that helps to run a better smart city using data. I was also the Microsoft Excel World Champion, using Visual Basic scripts to run analysis way before we have Python and all those data mining tools. I was also working in the Microsoft e-Research Center to create a platform that publish agriculture census data that we have collected and shared it with researchers around the world. I also sit in the Ministry of Education's expert panel to audit the bachelor's and master's of data science and computer science courses degrees for Malaysian universities. I'm sharing this so that you can have a better understanding about my background, and feel free to ask me any questions that I can help you with using my background. Alright, let's continue with where we've left off just now. So there are 4 types of content, basically photos, music, videos, text, and then we can find on almost all platforms, be it the more social ones like Facebook, Instagram, or more professional ones like LinkedIn or Quora. And this is what we call the unstructured data. And analyzing unstructured data will give us the variety of data that we need in analyzing big data, and combining them with breakthrough in the computational power, cloud storage, and it enables the possibility for us to achieve or to perform artificial intelligence or AI. Now think about it. If you look at the recently released Tesla robot, it's a combination of image, audio, video, sensors, and text information. So the robot won't be able to operate if you take any of this information out. So if you take away the image, it won't be able to see the surrounding environment. If you take away the audio, it wouldn't be able to listen to what people are talking about and wouldn't be able to interact with humans. And if you take away the videos or any of the sensors, it wouldn't be able to perform, right? And of course, text information is for it to be able to interact and communicate with human beings, because that's the only thing that we communicate. So if you think about the driverless cars, it works the same too, right? Well, if Tesla robot or anything Tesla is too far-fetched, then we can look at something that is more consumers related. Say, for example, Apple HomePod, Siri, Google Home, Alexa, okay, any similar types of these sort of voice control devices. While the user interface and the user experience is simple and streamlined, the process behind is not. Well, it involves the steps from detecting speech, converting those speech into signals, and then turn them into text so that we can analyze the user's intention from those texts, and then identify the questions, the actions, and also the keywords that are required. And from there, we need to send it to the server to determine what actions to take, or what results need to be returned to the users. And then we still need another text-to-speech synthesizer engine to respond in the audio form. As we can see, right, the large part of this process is actually relying on existing technology on text. And we can't perform those actions without being able to understand what the text is about. And therefore, text analytics actually plays an important role in unstructured data processing. Now, text data typically contributes to about 80% of the data that most organizations generate. You can imagine like emails, documents, messages, your knowledge portals, your forums, your wikis, and not to mention your social media data, Facebook posts, LinkedIn posts, etc. And those data are not stored systematically anywhere, and they are not analyzed in any meaningful ways as well, right? That's why we hardly see any companies analyzing text data intentionally or purposely. But the thing is, if you think about it, a company can see value almost instantly as soon as they begin to analyze text data. Say, if we start to analyze our customers' email, we can learn the typical questions and the type of pain points that our customers are facing. And these sort of analyses are 10 times more effective than the questions that we list in our FAQ sections. And we can also analyze our product reviews and comments to find out what our customers are complaining about, or what they are praising with our products, what they like about our services. And then we can further amplify these values to the next level by combining this unstructured data with existing structured data. And this will help us to uncover hidden structures and patterns in our structured data. And this cannot be done and cannot be detected just by using any traditional analytics software or even BI tools. So the core of text analytics begins with natural language processing, or in short, we call it the NLP. Natural languages refer to a language that is developed and evolved naturally in humans, such as English, Chinese, Bahasa, Russian, French, or Japanese. And the processing part, it means that we analyze the content and to extract meanings, intentions, specific semantics, and we want to utilize this information to carry out specific instructions. So let me quickly walk you through how NLP works. So let's say we have a text document, which is the quick brown fox jumps over the lazy dog. So the first step in NLP is to chop the sentence, okay, to break it down to the smallest information you need, which is usually a term. And then this process is what we call tokenization. So every single term here is also called a token in natural language processing. Now, before we proceed to the next steps, we need to think about a question, which is every word here meaningful? Probably not, because some of the words here like the or over, they do not actually provide any additional meaning to the document itself. Or in other words, if we remove it from the document, grammatically it's wrong, but it doesn't affect you from understanding the key key subjects in this document are still the brown fox and the lazy dog with some adjectives or some verbs in between. And this process is what we call the stop word remover. And we can now take this to the next level of processing and continue to perform other text analysis tasks that we want to. Now let's head over to the notebook and I'll give you a live demo. Alright, this is a Google Colab notebook. A Google Colab is an industry-grade IDE, integrated development environment, which we use to write data science codes in Python. So this is a very popular tool for among data science community. And if you don't want to use Google Colab, you can download and install your own versions, the local versions called Anaconda, and using Jupyter Notebook, it works the same. So first thing first, before we start any of our notebook, so if you are not very familiar with the technical details, that's fine. I'll share the link of the notebook later on. At least you follow the train of thoughts and you follow my workflow process so that you understand how we actually tackle a natural language processing task in real world. So let's import some libraries that will help us to run natural language processing tasks. So Python is just a programming language, so it is a bare bone. Yeah, it comes with nothing except some basic programming features, and all these libraries help us to achieve the task that we want to do. So the first one that we are going to import is Spacy. Spacy is a natural language processing library, and then we import TQDM, which is a progress bar for us to run long-running tasks, because the language processing task usually takes a while, especially when your data set is huge, and if you don't use this one, you might not know the progress, and you have no idea how long you need to wait. Okay, so you can either execute the cell, each of these is called a cell, by clicking the play button here, or you can just press Shift Enter. And if this is your first time running a notebook, it will take a while because it needs to initialize the kernel on the cloud. But after that, the rest will be pretty smooth. And once your cell has executed successfully, it will show you the running time. And also there's a number 1 here, right? You can see the 1 there. It indicates the steps, the process of your steps. And in the second cell, we are going to import other libraries, which is Pandas. Pandas is a numerical analytics libraries, and also we are going to import a list of stop words from Spacy. All right, the idea of stop words that I've introduced before. So run this cell as well. Then we're going to read our data from a URL. So the data set that I'm using today is what we call the TripAdvisor Hotel Reviews dataset. So you can take a quick look. It's a very straightforward data set that has only 2 columns. So the first column is a review, and then the second column is a rating. Okay. Alright, let's go back to our notebook, and DF here stands for data frame. Okay, data frame. So we want to load our data set into a data frame. Data frame help us to load our data set into our memory and give us a form of handling it like we are using Excel. So it gives us rows and columns. And if you have not seen CSV file stands for comma separated values files, which is like what we have seen before. Every single column is separated by a comma, and it's a text file. So it wouldn't be restricted to, or you have to open these using a particular special software. Yeah. And after we have load our data set, we can actually run another command called df.sample. So we can randomly select 20 rows from this to take a look. So the values of rating is from 1 to 5, and reviews is here. Yeah, is shortened because of the display. Or we can actually take one of those, say df dot, and read the entire review. Okay, so poor value stay, Monaco, Seattle, July, nice hotel price, da 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 da. Then we can go ahead and initialize our spacey. So initialize our spacey library and using NLP as a variable and in English language. Yeah, this is what we have set it, EN. And run this cell as well. Then we can proceed to prepare our data set. Okay, so alright, so let's take a look at our Alright, so the first step that we need to perform, of course, is tokenization, right? Because we want to break our text input document into a smaller unit, smallest information unit, which is a term or a word. So what we can do is we can take a look at one of the review. Okay, let's say so that we can check afterwards what it becomes, and then what we are going to do is we are going to convert our reviews into a list of documents, and then we are going to turn it into a set of tokens. Now, because this process takes a long while, so I'm going to wrap it using a TQDM wrapper function. And also we are going to take only the first 1,000 documents because of the time. Yeah. Later on, when you get the notebook, you can run the entire collection. So we're going to run this. Okay, and once I've completed, so this is what I meant, we can actually check again what is the before and after for the results. So, and we can run a length function, okay, call the length function of DOC tokens, the 10 document, to match this one, and we can see that it has 61 tokens inside. So we break it down to 61 words or terms from this particular review. So I basically check the length of the list to show the number of tokens. Okay, all right, and then let's move on to the next step, which is to remove the stop words. Okay, again, stop words means those words that appear frequently but do not add any semantics to the document, and removing them, and also the punctuation marks, because we do have some punctuation marks here, like hyphen, dash, slash, comma. Again, they do not add any values or any semantics to us or to the machines, to help the machines to understand our documents, understand the content. So removing them and punctuation marks will significantly decrease the computational time. So we're going to create another list called doc filtered. So this is for us to keep the documents which we have filtered off the stop words and punctuations. And again, for every single document in the DOC tokens, filtered tokens equals to token for token in the document. Now, if not, yeah, we want to remove those tokens that is stop word, and also we want to remove those tokens that is punctuation. And then after we have filtered it, we have cleaned that, we just put it into the new list called the doc filtered. So run this, and we can quickly check the results. So we can call the DOC filtered this round and look at the 10 documents, and we can see that it has turned into a list of tokens which most of the stop words are removed. Or we can run the length function again to check how many of the stop words, and 46. So we have removed 15 stop words. Yeah, from the original documents. So it's about, so we have removed about 25% of the stop words, or in other words, we have at least reduced the computational time by 25%. This part is the code that I get it from the official documentations in case you want to customize your natural language processing pipeline. So you can use these app pipe functions and introduce your own functions. If not, you can skip that. Alright, we can remove the rest of my testing code. And now let's move on to some more interesting use case. The first thing that I'm going to show you is sentiment analysis. So sentiment analysis gives you a score on the opinions or how people feel, the sort of emotions that they express while writing their review. So first thing first, let's import another library to help us, which is called the NLTK. It stands for Natural Language Toolkit, which is another very popular natural language processing toolkit that we use in Python. And then in particular, we are going to use something called the Vader lexicon. So we are going to download the Vader lexicon. So let's run these two lines first. Vader is actually another open source project. So everything that I've shown you today is based on open source projects and also industry standards. Vader is a short form that stands for Valence Aware Dictionary and Sentiment Reasoner. And it's very powerful with a lot of special features, like for example, is able to understand negations, understand short form contractions, and also understand many slang words, and also emoticons and acronyms as well. So to use the sentiment analysis function, we need to import nltk.sentiment.vader. We need the sentiment intensity analyzer from the Vader function. So we are going to initialize sentiment analyzer. Okay, sentiment intensity analyzer, and we can do a quick test. So to calculate the sentiment score, we need the functions from the analyzer called the polarity score. So we can say score equals to analyzer.polarity scores. I'm very happy with my results today. Okay, and then we check the score. So given this sentence, I'm very happy with my results today. It gives us polarity scores. Compound score is the overall sentiment, so it's positive 0.64. And then if we break it down to negative, neutral, and positive, it will be 0.417 positive and 0.583 which is neutral. So I'm quite happy with the with my results today, and this is the sentiments. Or we can try another one with negative sentiment. So we can say score. I have lost my keys again. Dang. Alright, and look at the score. Okay, so this time around we have expressed our frustration because we lost our keys again. So the neutral score is 0.659, but the negative score is 0.341. So the overall score, the compound score, is negative 0.38. Yeah. What we're going to do next is we're going to apply this to all the documents or all the reviews in our data set. So we can say sentiments equals to analyzer.polarity scores bracket D. Okay, so where does the D come from? For D in TQDM, so we wrap it in our progress bar wrapper, df bracket review. Okay, so we can run this. It's going to take a while to run, but it wouldn't be too long. This is much faster than the tokenization. Okay, once done, we can quickly take a look at, let's say, the top 10 results. So give you the score, okay? And the next step is to convert our results into a data frame so that we can join it back to the original data frame. So what we are going to do is we're going to call this a sentiment data frame, and this data frame comes from our sentiments result. And what we're going to do is we're going to say df equals to df.join sentiment df, and we have successfully joined two data frames together. And now you can see that each of the reviews comes with rating and also the sentiment score, negative, neutral, positive, and also the compound score. I hope the demo part is not too technical for most of you, because it's really important for us to understand how easy it is to extract sentiments from text and combine it with your existing data set. So now you might be wondering, like, okay, so what if I've gotten the sentiment analysis? I know that some customers, they are not happy, some customers, they're happy, and what's next? So with that information, we can further investigate and gain insights from those feedbacks by combining the sentiment score with our ratings. And for example, we can look at what are the good things, what are some of the good things that people say when they give us a low rating. For example, let's look at this 1-star rating, but it has a high compound score of 0.97. So it's basically a customer, a user that's complaining that the hotel is not good, 3 hours sitting at the lobby waiting for the room to be clean, blah blah blah. But look at the part where I highlighted. It says, well, breakfast convenient. Okay, that means the breakfast is convenient, or the service is not that good, right? Not that great. And then there's also another part. It says the pros. The stay is good, short walk into the metro neighborhood, quiet, safe, and clean bathrooms. So this, although it's a really poor rating, like just a 1-star, but the overall sentiments of this comment is good, right? Even the bad part is not that bad, and you can still extract some of the good part, so you know that what are the parts that your customers like it. Now, if we look at the opposite of the first point, right, we can also look at poor feedbacks in our reviews, but it actually has high rating. So for example, this review has a rating of 5, which is really good, right? But if you look at the sentiment score, it's actually not that high. And if we read further, all right, if we take a closer look, it says that Casablanca NT is nicer. So it's actually saying the other hotels or the other apartments is actually nicer and can't wait. All right, the staff is not helpful, and the location is good, perfect for sightseeing shows. And the help desk, the front desk people greeted, eager to assist. But going April, they definitely going to stay at Casablanca. And also we can look at the correlations between the ratings, the sentiment score, and also the keywords, and based on that we can do some predictions and other types of modeling as well. Alright, next up we're going to look at another useful technique that we use in analyzing text data, which is what we call the topic modeling. Now, to find the correlations between the sentiments, the rating, and also the keywords that we use, that the customers use in giving their reviews, we need to use another technique called the topic modeling. Topic modeling is actually an unsupervised machine learning technique, so which means that we don't have to provide any training data. We can just take whatever data that we have and run it through, and then what it does is it automatically clusters word groups that best represent a set of documents. So for example, if we further study those reviews or those bad reviews, right? These are the keywords or terms that always appear in there. So people complain about the staff, people complain about the beach, people complain maybe about the dirtiness, the conditions of the room, the food, and the beach. And these are what people are usually complain about when they give bad reviews. But if you look at those good reviews, and you see a different set of keywords, right? So you will see things like great, maybe it's near to the airport, the staff are nice, the food is the best in the town, and the other set of the keywords maybe like hotels, suite, so they like the suite arrangement of the hotel, maybe it's close to Hollywood and it gives you some Hollywood-like feelings, and then Renaissance style as well. So different keywords among between the good reviews and bad reviews, which will give us a lot of insights, or we can find out more correlations between the rating itself and also the keywords. So let's see how we are going to implement this in Python, okay, using our notebook. So we're going to import another two libraries, which is called the Gensim and also the Gensim Copra. Gensim is a topic modeling library that helps us to train large-scale semantics NLP models, and it helps us to represent this text as vectors, because computers don't understand text, they only understand numbers, or to be exact, they only understand signals. So we have to convert those texts into something that is computable, and then we need to represent them in the form of a vector. And in linguistic or in language processing, corpora is actually the plural form of corpus, which stands for a language resources consisting a set of text. Yeah. Then the next step is we need to generate a list of words, which we call it a dictionary, so that we know what are the words that we use, or what are the words that appear in our documents. So we say words equals to corpora.dictionary.filtered. And then we're going to convert all our documents, which is our reviews, and then we are going to convert them into a set of corpus. So we can use, say, corpus equals to words.doc to BOW. Now BOW stands for a bag of words, which means the order of words are ignored. Yeah, we don't care whether is it a quick brown fox is quick, it doesn't matter. In this case, we are not going to retain the order or the sequence of our words. And then for each of the document in doc filter. And the next part is to build our topic model using LDA. LDA stands for Latent Dirichlet Allocation Model. If you're not familiar with this term, or you have not heard about other topic clustering, like let's say K-means or hierarchical clustering algorithms, it doesn't really matter. This is just one of the, I would say, most effective and most popular topic models used in our industry. So topic modeling is an unsupervised technique, right? Remember, so we want to find the natural groupings of that, and LDA is a method to help us to find whether a document, what are the topics inside this document. And one thing that you just need to remember is LDA is good, is powerful, because it's not a hard clustering algorithm. Most of the clustering algorithm will say that if this particular document belongs to topic 1, and then it cannot belongs to topic 2. But LDA use a probability model, which means that there's a probability of this particular document belongs to topic 1, and then there's another probability that it belongs to topic 3, for example. So this is the very, I would say, the advantage of using LDA. And I'm just going to copy and paste the model training code from the documentation here. And you don't have to understand every single thing. You just have to remember a few things. The corpus is the corpus that we have just created, and ID to words is the list of words that we have created, which essentially means our dictionary. And this is something that's important. Number of topics. So how many topics you want to generate? You must have some sort of, like, I would say, gut feeling that how many topics that you want. I choose 10 as arbitrary numbers, and then random states equals to 2. This is for us to perform our experiment and make sure that the random seed or the random number is always consistent. If in production, you can just remove this, and the rest of the parameters you can just leave it as it is, and then run it. So it will take a while to build the model. And once it's completed, we can call the LDA model.show topics, and it will give us a list of topics with the respective keywords and also the probability of that keywords, that words in that particular topic. Alright, so next step, I'm going to show you how to visualize this by using a simple bar chart. Again, we're going to import another library called Seaborn. So Seaborn as SNS, and we're also going to import a plotting library engine called the matplotlib. And I'm going to configure my to perform some configurations. So to set the figure format to Retina, for those of you who are using Mac or who are using a high resolution monitor. And also we are going to set our figure size. Okay. And to a ratio of 11 and 8, and we're good to go. Okay. And the next part of the code, I'm not going to walk you through. I'm just basically copy and paste from the documentations. But what it does is it will draw a set of charts, a set of bar plots or column charts, and based on the topics. So there are 10 charts here exactly. And those are the keywords and the respective probability of those keywords in that topic. So we can say, like, we look at this one. Okay, we can look at this. The review is mainly about hotel rooms, great, nice, stay, location, then staff, night. So you can see that people who talks about this hotel, they are pretty happy, and this should be a review of those who are happy and satisfied with their stay here. And we can look at some other parts as well, like this one. They talks about the parkings, and then the comfortable of our beds, and this one talks about the rooms, the staff and lobby areas. Yeah, so we can get a lot of insights and correlations between different topics and also the ratings. And alternatively, we can also visualize our keywords using something called the word cloud. So it's another, well, I would say, a fancy type of visualization. I'm just going to copy and paste the code here so that you know what to do later on when you revisit the notebook. You basically just have to follow my workflow, and you just have to change your data set to your own one and change the respective column names, and you're good to go. Okay, this code I have used it many times, and this is not a coding talk, right? This is more for me to help you to understand what are the industry practices and how do we analyze unstructured data. Okay, so we are going to draw this word cloud here. Okay, so you get a different view and different ideas, and all you have to do in terms of like understanding the words, probably hotel and room is the most popular word that's used in all of our reviews, and these two probably should these two keywords should be removed. In fact, right, should be considered as a stop word as well. But you do see that people talk about the food, talk about the beach, talk about the vacation style, the pool and stuff. So you and also breakfast. Yeah, you will get a very good idea and indication what these documents and what these reviews are about, and the rest of the stuff are depending on how you extract those information and aggregate them into different views, I would say. All right, the next thing that we're going to talk about is how do we build a search engine for ourselves. So there are times where we need to build our own search engine. We need to retrieve the text information from our database. For example, if you are working for the bank, we'll need to retrieve the customer details for compliance purposes. And in products, in sales, right, we might want to look for products that matches a particular descriptions. And in service industry, we might need to look for customer feedback that contains specific keywords. So these are some of the use cases that we need to build our own search engine, because we can't get Google to index all this for us, and we're not building a search engine just to be the next Google, as I mentioned, right? So for example, if we want to look for the reviews that contains the keyword has, let's say, nice breakfast. So if we use some basic terms or words matching algorithm, it will just return us with a list of reviews where the terms nice breakfast appear. And it gives us things like I just took a snapshot of that, like stuff helpful, breakfast is nice, early difficult, etc. Okay, and the list goes on. You might have 50, hundreds of reviews, comments that contains the word nice breakfast. So there are a few questions that I would like to ask you, or I would like you to think about. Number one is, are these all the results, are they all related to our query nice breakfast? Okay, maybe they are, but how related are they, right? Because if they are not all related to our query, then how do we determine which documents are related and which documents are not? And in other words, how do we rank them based on their relevance? And number three is, does a high occurrence means important? So if you keep seeing the word nice in a particular document, a particular review, or if you keep seeing the word breakfast many times in a review, does it mean that that particular review, that particular document is more important than the others? So these are the three questions that I want you to think about. You don't have to give me the answer right now, but I want you to keep that in mind. Obviously, the answer for question one is the no, right? But even if all the documents are related, okay, we that means we put in nice breakfast, and every single reviews, every single documents, they contain the nice breakfast, the term nice breakfast are related, okay? But we still have a ranking problem. Because like what I mentioned in question 2, how do we sort the documents based on their relevance? How do you know which one is more related to what we are looking for and which ones are not? And also, number 3, how do we give proper weights to all the terms in all the documents? If it is a review that only talks about breakfast, and the term nice breakfast will have a much important weightage, but if it is a review that talks about everything, then the importance of the terms nice breakfast will definitely be reduced. So in order to do that, we have to convert all our terms from the text form to a numerical form. Or to be exact, we want to project those texts into numbers and to become a vector. If you don't really understand the concept of vectors, or you have forgotten about it, but since it has been a while from your high school, you just have to remember that it's a measurement that has both directions and magnitude. So it's not just a number, because we have a lot of terms in the vocabulary space. Yeah. So if we use the word, I'm going to use the word nice and breakfast here as an example. So it will be something like this mathematically, and review 1 and review 2, each of them represents each of them represents a document, and for each document, their weights of the term nice and breakfast are different. Yeah. And then after we have done that, we will need to use a formula to measure the similarity of these two documents. So we are going to use something called the cosine similarity. So cosine similarity is a measurement that measures the similarity between two document vectors using the cosine formula, which ultimately measures the angle between these two documents. So the values ranges from 0. If the answer is 0, it means they're completely not related. And if the answer is 1, that means these two documents are exactly the same. They are identical. Alright, so let's go back to our notebook and see how we can implement that. So in order to do that, we are going to import a couple of more libraries here. First thing first, we need to import the feature vectorizer. So we're going to import the TF-IDF vectorizer. Okay. Before we continue, let me give you a quick introduction on TF-IDF, which stands for Term Frequency Inverse Document Frequency. So you just to learn how do we represent the words in a document. Say for example, we have a document which contains a sentence, the sky is blue. Of course, first thing first, what we need to do is we're going to tokenize it into 4 tokens, and then we're going to remove the stop words, which then leave us with 2 tokens, which is sky and blue. And usually what we will do is we will calculate the frequency or the occurrence frequency of a term. So we turn this in order to turn this document into something that is calculatable, right? So we turn that into a vector which represents sky is 1 and blue is 1. You won't feel the problem if we were just counting the frequency using a very short documents, right? But if we put them into a real world context, you can see some of the reviews, it could be long, right? Like for example, this one, the one on the left, and some of the reviews, some of the documents, it could be short, or some of them with a moderate length. And this is where your keywords, your frequency become less useful when we are trying to use it to represent a document. So if we look at cat as a keyword, right? There are 3 cats in this particular document on the left, and then most of the other documents on the right hand side, we only have a single occurrence of cat. So if we use term frequency, the term frequency of cat in this document will be 3, and the term frequency in these other documents will be just 1. But if we just represent them in 1 and 3, it will imply that the word cat is 3 times more important than the other documents here, which is not so true. So if we just represent our documents using the frequent terms, the first problem is frequent terms are insufficient to represent the information in a text collection. Meaning when the documents has a terms that occur frequently, does that mean that that term is important, or does it mean that it's not? And number 2, frequent terms are less informative than rare terms. If we look at our previous use case, the example here, right? the word cat appears in every single document. So the uniqueness of the term cat is definitely much more lower than other terms, like for example beautiful, pea green boat, honey, or other words that has a lower occurrence. And third problem is that we need to have another indicator to help us to factor this into our model for computation, so that we can get a much more accurate representation of the importance of a term. And that's when we need to introduce another metric called the document frequency. So here are some of the terminologies. We already know that term frequency, or what we call TF, is the number of occurrence of a term in a document, right? How many times it appears in a document. And document frequency is actually the number of documents where T appears. So if it appears in one document, it doesn't matter how many times it appears in the documents, we will count it as 1. Okay, it's the times where the number of documents where the term appears. And N represents the total number of documents in our collection, in our data set. Okay, so DF is the number of documents where a term T appears. Based on the definition, if we look at our previous data set, the term cat has appeared 6 times, and hat appeared twice, and so on and so forth. If we look at these, right, it means that the word cat appears in 6 documents, which is 3 times more than the word hat appears. But remember what I shared with you earlier, right? This does not mean that the word cat is 3 times more important than hat and 6 times more important than film. So what we need to do is to calculate another metric called the inverse document frequency, to flip that around by dividing the total number of documents with the document frequency. So that will give us a table like this, right? So we successfully turned the importance of cat from 6 to 1, and then the hat from 2 to 3. By inversing the document frequency with the total number of documents, we can immediately see the effects. But this is still, from a macro perspective, we look at the entire collection. But the problem is, it overpowers the term film. Now we introduce another problem here, right? Now we are saying that the word film is 6 times more important than cat, which it doesn't seem so, right? Although it's rare, but intuitively speaking, its importance cannot be twice as important as hat or sunny. Yeah, so if you think about it, right? So we're seeing this because our collection is super small, and if we look at our collection size like Google, it wouldn't make any sense when some keywords is 1 million more important than the other keywords just because it appears in 1 million documents. So the mathematicians are very smart. They came up with a way that helped us to normalize the effect using a function called the logarithm. So logarithm is the inverse function to exponential. It's a very convenient way for us to express large numbers. And by applying it to our IDF, it helped us to reduce the effect of the increment in a way that's more gradually, more gracefully, and less dramatically. So if we take a quick look at the table and the chart, right, we can see that log 1 million is only 6. So it gives us a smoother scale when our data collection size increase. So if we apply it to our document, we can see that right now the importance of cat is reduced to 0, because it appears in every single document. The importance is as good as not important at all, and the importance of film is 0.778, which is almost double, less than double of sunny and hat, which is a more realistic representation of the importance. So now that we have understand TF IDF, we can use that to vectorize our documents. So we're going to create a new instance of vectorizer using the TF IDF vectorizer, and we're going to generate a set of TF-IDF features using the vectorizers on our reviews. So we're going to call it TF-IDF equals to vectorizer dot fit transform TQDM DF review. Okay, and then let it run. Okay, now next we are going to formulate our queries. So I'll say query equals to nice breakfast. Okay, and we also need to create a feature. We also need to vectorize this query in order for us to do the calculations, right? To compare it with the other documents. So we're going to call it the query TF-IDF equals to vectorizer dot transform our query. So this is a bit different there. Over here, when we want to build our vectorizer from the original reviews, we are going to use fit transform. But since we have already built the TF-IDF features and our vectorizer is trained, we can simply use that to transform our query. Yeah. And the next thing that we need to do is to calculate the cosine similarity score between the query and all the other documents in our data set. So we are going to import the matrix pairwise, import cosine similarity. Okay, you don't have to remember all this, just remember the workflow and my thought process. I did not memorize any of this at all. Okay, cosine similarities. All right, and we're going to say cosine similarities equals to cosine similarity of what? Of our query. Okay, and also our documents, our data sets. And then we have to extract the IDs of those reviews and inspect the results. So we're going to say results equals to cosine similarities. We need to flatten it first because it's a multi-dimensional array. And then we're going to sort the list. Let's say we want to look at the top 10 results. We are going to start from -11 to -1. Okay, we look at it from the back because it sorts in the ascending order. So the results contains all the IDs of our reviews, so we can iterate for ID in our results. We are going to print df ilog. We get the ID and then we print the review. We're going to print a couple of lines. Okay. So this is the results from our query. Yeah, the review. So we can take a look at some of them. Yeah, nice stay, nice functional hotel, nice expensive breakfast. So the way, because we are using back of words, yeah, so the word sequence and the word orders is not retained, meaning that as long as the review contains nice and breakfast, it will show here. So if you, but most of them, they are related because if you look at the content, right, you understand what I'm saying. Okay, like say nice hotel, nice bathroom, yeah, great internet, free internet, great breakfast, and then yeah. So I'm pretty happy with the results. Okay. So what I have shown you is a typical use case on how to analyze customers' reviews based on our services, and you can see this a lot in e-commerce websites that where people talk about their products, people talk about the quality, people talk about different stuff, and there are many other use cases that you can apply NLP. For example, search engine. Now, of course, I'm not suggesting you all to build another search engine to go against Google, right? We already have DuckDuckGo. But there are times where you need your own in-house search engine, or I would say a mini Google, that can index all the documents that you have. And making your own search engine can be quite beneficial, especially for those companies that has been existed for quite some times, and also for startups, because it helps you to keep track of your competitions and gather important data information about the customers. And also sometimes you have meetings and you have a lot of ideas that you want to capture, but as time goes by, you lose track of them and you don't know where to find them. And this is especially useful for SMEs, medium-sized company to large companies who already has its own internal knowledge base or wikis. Companies like banks or sensitive industries that always need to deal with regulations and compliance issues can totally utilize an in-house search engine to address a lot of the issues. Secondly, chatbots. Well, chatbots were once very hot in the past 1 to 2 years, and to a certain extent, which I personally think that is way overrated. Many companies deploy a chatbot solution just as a non-human alternative so that they can provide what I call it the pseudo customer service 24/7, right? Or they simply just simulate the phone menu, press 1 for English, and then press 2 for customer service, and 0 if you want to speak to an operator. So most of the chatbots that we have encountered provide a similar experience. So it does not really have any disruptive or innovations behind. But the real purpose of chatbots are for us to streamline the interactions between people and services so that we can enhance our customer experience. And chatbots also offer companies new opportunities to improve the customer engagement process and also the efficiencies. And chatbots does that by reducing the typical cost of customer service is done properly. So for example, you assist your customers in looking for a particular user manual or addressing a particular technical issues, or to at least direct them to the right places that they need to go to. And the next thing is product review. Well, I've shown you and demonstrated how we can use product reviews in the service industry by analyzing the reviews from hotel customers. Of course, we can do the same for product-related customers, product-related companies like e-commerce sites, and also any other service industries. And NLP allows us to analyze reviews at a scale that's difficult to be performed by a human. Right? And we can then identify and fix issues with our products and services and find out what are the main problems that prevent people from making a purchase decisions, and ultimately use that to improve our business processes. Of course, the machine probably can't write a novel or fiction yet. They will become a bestseller. But the rise of GPT-3 and deep learning has made it possible for the machine to write content for us automatically. And those content they write are for machines to understand. Okay, that's totally possible. What does it mean? It means that you can build an AI writer to learn your tone, your emotions, and help you to write content that's targeted for other machines like Google bots to read, so that you can use it for SEO, search engine optimization purpose, to index your websites and push up your rankings. And you can also use it to respond to standard inquiries on Facebook, Instagram, and rather than relying on private message, PM, or manual inbox direct messages all the time. So I hope my talk today has given you enough motivations to start looking into unstructured data. And in a nutshell, here are the 3 benefits that I would like to share with you about unstructured data that you should be looking into it. And most importantly is to think about how do you align them with your upcoming business strategies or enriching your existing models. So first of all, unstructured data plays an important role in the world of big data. But in the world of big data, individual data points, they don't carry much meaning. It's about connecting these data points together. And when you connect these points, or when you connect these dots, you start to see patterns that can help you to make more accurate predictions. And connecting those dots is not as simple as it sounds, but it should not be too difficult if you have sufficient domain knowledge, as long as you understand what you are analyzing, what sort of features, what sort of variables, the quality of your data, and what you are expecting after you connect the dots, and you should be fine. And once you're able to do that, right, unstructured data help us to provide comprehensive answers to our business questions, and even help us to ask business questions with a much higher quality, which means we can use it to answer business questions that you probably unable to answer in the past if you don't analyze unstructured data. Like for example, you wouldn't know the preferences of your top customers, and you wouldn't know what areas that your competitors are focusing, and you wouldn't be able to detect signals earlier than your other competitors. And bear in mind that the structured data the unstructured data that I'm referring to are not limited to text. I use text very often as demo, as example, and also within the businesses, because it's easiest and cheapest to obtain. It's very easy to get it, very easy to even store it. You can also analyze other data, other unstructured data like sensor data, video tracking data, audio records from the call center. There are data everywhere. If you take a look, you just need to make sure that when you're analyzing this data, it does not invade the privacy of the users, and at least you inform them when you are collecting their data. And obviously, when that happens, we have additional meanings, insights, and we're able to answer more business questions. It's natural that it will give us more certainties when we are making decisions. And that would take away a lot of guessings and gut feelings from our decision making process. And before we end today's talk, I would like to share 3 steps moving forward with you, so that you can implement that, whether is it in your own career or is it at your own business. Step number 1, start identifying useful unstructured data in your organization now. There must be some sort of unstructured data that you can find. It can be text data, that what I've shown you. If you really don't have anything like that, you can get some audios, videos, extract something from the social media, and that can be used to correlate with your structured data and see which one helps to unlock more potential values. For example, one of my students is they're working in a footfall analytics company. They use videos to identify hotspot, to get to know where people stop in a shopping mall, and use that for advertising purpose and pricing their ads. Step number 2, assign data owners. Well, of course, we understand that sensitive data is spread out across your structured systems, like your ERP applications, and also unstructured data like your emails, your log file, customer reviews, and they live in a system, or they co-share a servers, and you might have different cloud systems, and you use today because of sharing and collaborations. And that's why it's important for us to identify some data owners. Okay, if you really can't find that many at the beginning, at least you try to identify 1 or 2 from the key person or the key departments. Data ownership is not really a role or a paid position. It's more like a responsibility, a mindset, and most important thing is a commitment. And this person must be willing to spend time to understand data, and they believe that data is useful. They believe that data is going to do good, and it's understanding. They understand why the data is important, so that they have a good they have the desire to make good use of the data. Yeah. And last but not least, I have seen many projects that fail because they did not follow this mantra. Okay, start small, think big, and scale fast. And some people they mess up, they reverse the order. Start big, and then keep shrinking the scopes. And of course, they won't be able to execute and scale fast, and that will lead to failure. So do not try to digitally transform the whole company just yet at the very beginning. Start from a small team, ideally like a department level at least, and then think of how we can expand it to the larger employee, larger or to more departments. And if you are working on the consumer side for the customers, we'll do the same, right? Do not apply everything, your model to the customers first. Find a small group and test it with them, evaluate, track the results, and then we figure out how to scale. Alright, that's it for my tutorial today. So feel free to download the slides and notebook from the following URL, and also connect with me on major social media platforms using the handler Dr. Han Lau. And I'm ready to take some questions now.